I mean, this is the topic for today. Why do I need all this gear to make the wireless systems work? And we had several questions come in and we're going to address that. So it is a little, it is a little tricky sometimes for those that may be new to this, or if it's just one of those things you haven't had a chance to learn about it yet. So let's think about these two questions to answer the question of why do I need all this gear? How many wireless microphones or IEMs are you using at once? If you have three or more channels of microphones or IEMs, you need essential components to complete your system. The next question you can ask yourself is, where is the rack located, the wireless rack? Or where would you like for it to be located? If your answer is front of house, the mixing position, or it's in a closet, or it's more than a few feet off the stage, then you probably need components to complete your system. I was talking to somebody last week and they said, well, listen, Danny, why are audio essentials, extra stuff? Why is it necessary? But I picked a great wireless system from a well-known brand. So why do I need to add accessories to my mics or my in-ear monitors? Well, it's because wireless mics and in-ear monitors are sold as individual items and not as a system. To make them work together, you have to have a system that combines those in the right way. Let me give you an example. If you want to buy a PA speaker, if you need a speaker system, buying a PA speaker isn't enough. You have to also have these other things. You have to have a power amplifier to power the speaker, a DSP that does EQ, crossover, delay, and so much more. You may have to have a stage box, a sound console, obviously, then inputs, mics, cabling. And then after all of that's put in, you have to use Smart Tools software or one of the softwares to tune the system to the room. And all of those things have to be done in order. You can't just buy a PA speaker. So if you have a wireless mic and you buy a wireless mic, or you buy 8 wireless mics, whatever it is, what you get is a handheld belt pack, a handheld mic or a belt pack, and a mic receiver and a little whip antenna that comes in the box, and that's all you get because it's sold individually. But you need, for a system, you need all these other things. You need antennas, possibly bandpass filters. Those may be optional, but a distribution box, a distro box for 3 channels or more. You need cabling. You need setup tools to coordinate the system. That's a spectrum analyzer. We're going to talk about that in a little bit. And you're going to have frequency coordination at the end, some kind of software. Wireless System Builder is the one that's on our website, and and it might be Wireless Workbench or sound based. We're going to get into that. And it's the same with IEMs. If you need a system, you don't need just the belt pack and the transmitter and the whip. You need these other things as well. So, if these are essential, what are the problems, the issues that you might have if you don't use the accessories? Well, you already know the answer to that question. Dropouts, frequency interference, polarization. We're going to talk about some of these problems that you have. Polarization, multipath interference, poor frequency coordination. So the essentials that you need to add to that wireless mic or that IEM, an antenna, a distribution distro, a transmitter combiner, interference filters. You can see those things. And so let's take these one at a time. A remote antenna, what does it do And why do I need this? Why do you need this? Well, an antenna focuses the reception energy of the microsiever's directionally and dramatically improves signal strength and reception coming from the microphone transmitter. So you have a directional antenna that points at the place that you need to cover. You don't need to cover the whole room. You need to cover the place where the microphones are going to be. So a remote antenna directs all of that energy to that place. Wireless mics need 20 dB of noise floor in order to stay on the air. And so a remote antenna strengthens the reception of the signals sent by the mic so that that you get more a higher spike in your microphone signal here that stays above your noise floor. So that's very important. And then also, um, our antennas are specifically designed and engineered to solve specific problems, transmission and reception problems that are common in RF systems. What we do, what RF Venue does, is we make mics and IEMs work and sound better in any environment. And we solve these kinds of specific problems, and we're going to talk about those. Our antennas look funny, but there's a reason for that. They look funny because they're engineered to solve specific problems. I'll give you an example. Our diversity fin antenna is strange looking. It does have the look of a shark fin that you would get from the big name companies, but it also has those two dipole antennas that on the side. So what is all that about? Well, the diversity fin is designed to eliminate polarization dropouts and multipath interference. It's two separate antennas turned 90 degrees so that you pick up signals in each polarization. Let me explain that. In this picture, I have a picture of a microphone that is held vertically. On the right side, you see the A and the B side of the reception, and the strength of the signal that comes into a single receiver on the A side and the B side. Right now, since our antenna is vertical like this, if the signal sent out by the microphone it's polarized to the vertical like this, it matches the direction of the antenna, and so it's very strong. The signal is very strong. But as the microphone turns, notice that the A side starts building and the B side starts going down. So the further you go to the other side, now the polarization is horizontal, and in a normal shark fin antenna, you would lose 21 dB, or roughly an estimated 20 dB of signal. But with the diversity fin, you have these dipole antennas that are horizontal, so it takes care of that polarity issue. It would be like mounting another antenna sideways so that you can pick up those other things. Now, the other thing another problem this helps is multipath interference. Richard, why don't you talk about that?
Hey guys, yes. Thanks for having me here today. Of course, it's always enjoyable to 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 talk about our message to help other people, and we simply want to set you up for success. So when you just discuss multipath, when you're walking a transmitter around, if you're having a handheld in your hand, or if you're sending a signal out of a in-ear monitor antenna, it's reflecting everywhere. And there's a true balance between a direct signal to the antenna and all the other reflections that happen in the room. And your job is to make sure that the reflections don't get out of control. When reflections get out of control, it becomes multipath, which becomes destructive at your receiver. So that's why, yes, when you create a remote antenna, you're controlling the multipath. You're focusing on stuff coming in. When you're using an in-ear monitor with one antenna or multiple in-ear monitors with one antenna, you're reducing the amount of reflections in the room. So you got to look at it both ways with microceive and IFB or IEM transmit. Reducing reflection is helpful as long as you don't get rid of reflection. So that just tells you if you're outside, when you have no reflection, if you're outside of a building, yeah, that's going to be hard to get a signal because the reflections aren't helping you at all. So just remember, there's a balance. The balance is helped by choosing the right antenna and put in the right place.
Right. And one of the unique things about the diversity fin, it's two antennas in one. So you run both the A cable and the B cable, the diversity cables, both to the same antenna in one location. So it cuts down the number of reflections because there's only one antenna. There are those two antennas in one place as opposed to being 6, 8, 15 feet apart. So here's a couple of fun pictures that the chosen set. My good friend Mark is the sound production guy there, the sound recorder, and he's a big fan of RF Venue. Here's another picture of him. And then several different installations. You can see that this is directional. It focuses all of that 120 degrees into the direction, and you can see the direction and point the antenna just like in that center picture there. Our diversity architectural antenna, this is basically a diversity fin in a box. It's two antennas rotated 90 degrees from one another, so it covers the horizontal and the vertical polarity. It comes in black or it comes in white. It can be painted so that it just disappears into the wall. Here's a couple of pictures of that folks have sent us using the diversity architectural. It's attractive. It takes care of the times when your floral committee comes to you and says, "I don't want that big ugly antenna in my brand new room." So here's a great installation at Grace Church. I'm not sure which Grace Church this is, but you can see the two squares there in the corner. One of those is for mics, and one of them is a circular polarized architectural for in-ear monitors, and no one would ever know that that is an antenna. Here's another quick picture. Also, the third antenna in this group of antennas is a diversity omni, and that gives 360 degrees. Most of the time in a church, you don't need a 360 degree antenna. You want to focus the energy and direct it at the platform. You don't want to put an omni antenna at your front of house mixing location because it may pick up the stage, but it also may pick up noise and whatever is going on in the parking lot. So that's a different form. Let's talk about circular polarized antennas. Generally, we market these for in-ear monitor. We have three different ones, but I want Richard. Why don't you talk about circular polarization because it's a little bit different from the diversity fin.
So I'm going to just to do a little recap on the D-fin and the D-omni by themselves. Is that yes, we are saying that you can have two elements, two receiver elements in one location picking up horizontal and vertical wavelengths. The traditional way, before the DFIN came out, was yes, I would have placed two antennas out there and spread them apart. But that it's also necessary. It's also needed sometimes. What we find, and over the years that I've been doing RF for other things with uh, events and things like that, is sometimes you need antennas to be spread out. Sometimes you need them to be like the DFIN is offering. So when it comes to CP antennas, it is especially true when you have a non-diversity receiver involved, like for example, in your monitor system with one antenna on it. And if you notice, like this animation is showing you a transmit going out to a receiver that's non-diversity. And when you change the angle of the receivers, the circular polarized antenna is creating all these angles coming out. So that is, it's like our DFIN in reverse, but it's basically doing it in a circular pattern. So if you compare circular pattern, circular polarized antennas with the DFIN, um, and you talk about receive, well, it's pretend that this transmitter is a handheld transmitter and it's going the other way. It's picked that CP antenna is picking up all the angles as well. And that's when you need two of them to do A and B diversity. And the most common choice of a CP antenna is when you're outside where there's no reflections and you have a very wide splay of coverage needed. So just you're going to bounce between the CP antennas and our DFIN quite a bit depending on your situation. A lot of times the DFIN will cover a lot of things, but if you have an extra wide area to cover or outside for sure, or in the case of the CP beam, extra wide and long distance away, that's why you choose a CP antenna.
Right. So you can see that the circular polarization really helps reception, um, or it enhances when you have a transmitting antenna like this. It takes care of the polarization problems that you have. As I mentioned earlier, we have three different circular polarized antennas. This is our CP stage antenna, circular polarized, a wider frequency coverage. And it's excellent for being up close to a performer. A performer can be within 5 or 6 feet of it and not have their in-ear monitor pack overloaded, like they might with a more powerful um, transmitting antenna. But in addition to being able to do, it's 120 degrees, by the way, so it covers it very well. But in addition to being good for being up close, it's also great for being outside. This was our first IP rated antenna, so it's IP rated to be outside, and it easily can cover something, a situation like this. Two of these mounted on a press box. It's not a diversity antenna. There's only one input, so you need two for diversity, as you can see in this picture. The premier antenna that we have for IEMs is our CP beam antenna. It's 60 degrees instead of 120 degrees, 60 degrees wide, and 10 dB of gain because of that directionality. And so anytime something is needed at a great distance, this is a perfect choice. And here's a great picture of the Toyota Olympics, the opening ceremony. This is not the Olympics that just happened, in the last couple of weeks, but in Tokyo, and they used our CP beam to cover when they needed, a great distance and needed it to be rock solid. Also, this picture, I put it back in here simply because I wanted to show you the CP architectural there in the middle. It looks exactly like the diversity architectural, but it's circular polarized instead. It only has one input so that you can transmit through for your in-ear monitors. There again, it's 120 degrees, and so that those are our three circular polarized antennas. Real quickly, I want to talk about the spotlight antenna. This is something most people are not familiar with. This I wasn't before I joined RF Venue. But this, what if your problem isn't range? What if your problem is crowded spectrum and you can't find enough tunable channels? Well, the RF spotlight it's low profile. It's only just a little bit more than a quarter of an inch thick, um, and it puts out a dome of coverage, and then outside that dome of coverage, nothing. So you don't have to worry about digital television that's across the street, or another church that's across the street that also um, has microphones. Even on your own campus, if you have a campus where you have a youth room that uses wireless, and your main auditorium, you can separate those with this. This is a great picture. You can see there they put a spotlight antenna on the drum stand, and this particular band out of Europe uses that for their in-ear monitors. So a quick recap, remote antennas, ours are designed specifically to solve those specific problems. And the next problem is antenna distribution. There were a couple of questions entered into the chat that said, "Hey, at what point do I need a distribution box?" Well, we suggest if you have three microphones or more, that's really important. The distribution system actively actively splits a shared antenna signal to provide buffered outputs for your multiple receivers. So you have an antenna that's receiving information from those microphones, and it splits that signal into outputs for each one of the receivers. So here's a great example of this. We call this an antenna farm, lovingly. This is a problem waiting to happen. If anytime you have antennas like this, they're touching one another, they're crammed together. It's dangerous. It's just like I said. It's just asking for trouble, because those antennas interfere with one another. So this is not a great idea. Here's another example that's really common in churches. A church that I used to attend, we had a rack. We had all of our receivers racked in a metal rack. That's your first big, no. And then we had all of these whip antennas in the bottom. Well, this is not really a good idea. What you need is one diversity antenna like this that goes back into the distros, and then the outputs of those distros goes to all of your receivers. So what it does is it takes this and turns it into this to eliminate all of that mess that goes on in the bottom. It gives you your antenna line of sight instead of being buried in the bottom of a console, under your console, or in a closet somewhere, or even off the stage, off the platform, one side or the other. It's always better to have a nice, clean line of sight for your mic, for your antennas. And we have three different distribution boxes: a 4-channel box, a 9-channel box, and a half rack 5-channel box. So, and you can combine and cascade these distros in numerous configurations. A 4 and a 9 together, 2 9s together. etc. And you can actually combine up to configure up to 81 channels of wireless mic on one diversity antenna. So that's distros. Our next step, that those essentials that are really important: transmitter, combiners. Richard, why don't you talk about our combiners and what they do and why they're needed?
Okay, I just answered a question here. Give me a second. So if you imagine the picture that we showed you with linear monitors in a rack and antennas tucked away or down low and in multiple amounts, you have just a wall of noise basically at your rack. So so the first thing you need to do is remote an antenna, but when you remote the proper antenna and you use a combiner to take all these transmit outputs into one antenna, that one antenna is away from your rack. It's for a good reason. It keeps that energy a little bit further away, even though if you have an antenna hooked up to your rack, there's still all this energy in that rack. It's not saying get out of this rack and go only out the antenna. There's a whole bunch of energy there. But having that antenna focuses the energy in one spot. It goes out and hits the wall in one orientation, and it reduces the amount of reflections in the room. So you're gaining two ways. Again, you're simplifying your rack and making less of a wall of noise there, and then you're taking it at the antenna and hitting the walls with less reflection, which creates less multipath for your room.
Excellent. We have three different combiners. You want to talk about those, Richard?
Yeah. So uh, we had a question just come in about how do I choose distribution? How do I figure out the amount of or the size of the distribution? Well, with the combiners, it's a little different because you can't cascade combiners. If you have an active combiner, which is everything we have here, and there's others out there, you can't cascade go out of one into another one with any of them. So what we do is we passively combine them. And if you notice, our combined 6 has a built-in passive combiner. And it's basically taking the output of one and an output of another, and you go into this passive combiner into the two inputs, and you go out of the output for your master antenna. So that it combinates 12 in-ear systems. You have to decide if you have. Most people have 8 to 16 in-ear monitors for band or for church. That's usually the natural count. So sometimes you have to run out two antennas. And you
One
can
for each combiner.
Yeah, so you don't necessarily want to keep combining them, and because what that does is reduces the output level of your final transmit. So there's a balance, but I would just say across the board with the two combined 6s, getting 12 is going to cover like 99% of what people's needs are. Then you go beyond that. Just call us if you want to combine more passively. We can help you with that, but just plan on running another antenna out too.
Right. And it's good to note that you can't go past these two even with our combined 6, you can passively connect these together, but you can't continue to do this and add a third or a fourth layer, right?
It's not recommended, but it doesn't mean you can't do it. You just have to remember, if you do that, you're losing your signal to noise is now being compromised. You don't want your signal to drop closer to the noise floor. So that's the only, and you could tell if you look visually at the noise floor with a spectrum analyzer, you can see what you're up against. But overall, it's almost easier just to run another antenna out for that.
So we've talked about the combiners. The next step is our interference filters, the bandpass filters. We actually have 5 different versions of this that come in different frequency ranges: 530 to 590, 470 to 560, et cetera, et cetera. And this is a picture of a scan that we did before we used the filter and after we used a filter. So you can see how much of how this helps get rid of noise. by putting a high pass and a low pass filter on the signal. This goes in line either at the antenna, or it can go in line the right at the distro, coming with the line coming in from the antenna. So and those are possibly optional. They're inexpensive, but it's basically buying insurance that nothing outside of the band that you select will get into your system at all. So it's very helpful. All right. So the next thing that we need to talk about is spectrum analyzer tools and frequency coordination software. A spectrum analyzer is an essential tool for monitoring and optimizing your wireless setup. It scans the RF environment and it identifies all of the active frequencies in your area so that you can avoid interference. We have a couple of different analyzer tools. We're not going to go into deep right now with these. We'll do that on a future webinar. But our RF Explorer Pro is basically a lab grade spectrum analyzer. It does a lot more than do just scans. It does signal loss and Wi-Fi scanning, et cetera, et cetera. Our spectrum recorder is very different. It records a scan every few minutes and then compiles all of those scans, and it can compile continuously for up to 90 days. So you can see history that goes on. And then our wireless system builder is on our website. This is like Wireless Workbench or Soundbase. We're going to talk about that as well. But the spectrum analyzer tools are very, very important. Let me give you an example of why they're important. Last week, I went out. I decided to do a little test on our wireless system builder. So here at my house in Northeast Houston, I plugged in my address. I said I want 8 mics and 8 IEMs. I plugged all of that into the wireless system builder, and this is what I came up with right here at my house. The red bands are digital television that are marked out by the FCC database. The wireless system builder assigned frequencies for my mics and the IEMs that I had requested. This is where most people stop in their coordination. The FCC database did its job. I avoided the TV channels, but you didn't have a scan. And so I took my RF Explorer Pro, went outside and did a scan from my front yard. And this is what happened. This is what I saw when I loaded it into the software. Notice that all of this area down here that was open in the FCC database is the highest noise floor in my area. And so if I had used this coordination at a church, a school, whatever, I would have serious problems because of this right here. And so this is the reason why you need a spectrum tool. You don't have to use ours, but you have to have some kind of tool, not only to plug it into the software and do that, but you have to have some kind of analyzer, a scan analyzer for the spectrum, so that you can avoid all of those difficulties. Also, if this is the G50 band right through here, if I have G50 microphone receivers and I press the button on the front, it will give me the best frequencies in that location, but it doesn't have a scan of the room, and it will it might assign these high levels right here. It might assign those. So punching the scan button on the top on the front of your receiver is limited. All right, so
Hey, Danny, real quick, I just want to comment on that. It's a great point. Everyone who's on this webinar really needs to understand that if you can't see the noise, because noise is your enemy, all this noise in this environment is why we don't understand how it, when things don't work, what's happening. Well, a scan and a picture of it truly tells you that answer. And all we're saying is that you can't just type in an address anymore to get data to know what to use. It doesn't work anymore because the database is not 100% correct all the time. And all we're trying to do is tell you to get to that 100% level, get a spectrum analyzer, look at the noise floor, and really take command of where you are with your channels. That's all we're saying is take it all the way to the top.
excellent. Here's a great question. Okay, okay, Danny, you've convinced me I need to have some accessories, but what about the big mic companies? Don't they also have accessories? Well, yes, they do. I mean, they have antennas. Some of them have antennas, not all of them. Some of them have distros, combiners, etc. But what I would say is at RF Venue, one of the things that we pride ourselves on is filling in the gaps that the big name companies haven't done. Our RF products are designed and engineered specifically to solve problems that are common in RF systems. The big name companies, they've concentrated on making mics and IEMs, and they've done a great job at that. They're wonderful products, and they have great features. But unfortunately, there's a lot of things that they don't concentrate on, and we concentrate on engineering uniquely designed products that solve problems that the big name guys don't solve. Things that are unique to us. The diversity antennas are totally unique to us. Nobody else has these antennas. The CP stage, the spotlight antenna, the CP architectural. We've developed our products to help you solve your problems, and we would love to do that. Lean on our expertise and our application engineers. And you can contact us if you look at the website in the upper right hand corner. There's a place where you can ask for help. So please do that. Also, for any of you that want to go in depth on frequency coordination, we have a webinar next week, March the 19th, and if you go to our website, scroll all the way to the bottom, there's a place that you can register for that webinar specifically on frequency coordination. And I think you're doing the training on that, aren't you Richard?
Yes.
Excellent. Mm-hmm. All right. So I know we have some questions.
Hey, Adam.
Hey, how's it going, guys? Great presentation. I'll be happy to call out these great questions we got for you in the last couple of minutes here, and really appreciate everyone's time and sticking with us here. So you highlighted some questions, so I'll call them out and you guys answer. The first question comes from Tyler. How can I set up antenna placement to be able to stand a session of season of stage design changes, video wall changes specifically?
Yeah, a lot of churches will do this. They'll change the look of the platform by moving the LED walls around in different locations, setting up different things on the platform to give the stage a different look.
I could answer further too. So I could give you an example. When the Christmas season went through, a lot of the churches around here that I helped get new stuff or enhance their system had Christmas shows, which were exactly what you're describing. And ultimately their antenna placement might come in from the side. You may not be in a traditional sense directly on the side of the stage, but you might be further in the house coming in. And that has helped people get around obstacles that are usually, so if you can imagine on stage right and left, when the talent walks through and they change the set and they're moving pieces, well, there sometimes isn't an ideal place for that area because of the obstacles. So you come out further in the house just a bit, you angle it down, you get up high enough, and that generally covers up most situations.
Maybe on the on the
Yeah,
lighting
exactly.
truss that's out front, if you have a D-fin that you can mount there, it
Mhm.
covers the stage. Possibly one of our CP stage antennas that is movable. You can put it on a microphone stand so it can be moved to different locations. The CP architectural or the diversity architectural, you can mount those on the wall or mount it on the ceiling pointed down.
Yeah.
That's what we did at our church.
Great. All right. Next question. I have 30 plus pieces of wireless gear. What's the best way to manage it and keep myself sane?
Yeah, but both Danny, I can answer that for you for sure. Go
Yeah,
ahead,
go
Danny.
ahead, Richard.
Okay, well, okay. So like when Danny presented his first few slides, it showed you what components make up a system. And it's not just your wireless mic handheld you hold. For regarding RF, it's everything down the signal path, downstream that you have to deal with. And on top of that, yes, you have a lot of people that want individual transmitters to talk or sing through. You have to have the frame of mind of I got to be organized. You got to tell yourself if I do this job, I got to be cool with how much I have to organize and keep track of. And it comes down to the amount of equipment that's out there and the frequency part. So to get the right frequencies, you have to have the certain tools to get there. And you are keeping track of a lot of little things. So I would just say the more you do it, the more you practice it, the more comfortable you get. And for me personally, I was in situations where back in the day, I just said, I'm gonna just go for it. I'm gonna do what I know I could do, jump right into something that's really big, but just get through it. But what helps me get through it is the organization. And writing things down is super important. We're here to help you with choosing the right gear. And we realize that your shows are going to probably grow over the years. You just need to be on top of that management step and keep track of your frequencies. Don't just choose and change things without really seeing if they're all working together. That is a very common thing to go into a church or to a school or to a venue and go, well, it looks like you haven't been managing your frequencies and your equipment. So let's just help you start over in a sense. That's my approach.
All right, great. So next question, we got time for a few more here. Can directional antenna systems avoid interference from broadcast TV signals when using wireless mics in the same range?
So I'll answer again. So any antenna is going to pick up noise if if you're tuned to the same channel as a broadcast TV station is. Any antenna is going to pick it up. Now, a directional antenna may make it worse depending on if you're pointing towards the noise source. So if you're outside, yes, you're going to pick up more TV no matter what antenna. If you're outside and you point an antenna towards where the TV signal is coming from, like on the highest point of the city, it's going to come in a little hotter. So you have to you're using directional antennas to sometimes avoid the local noise around you, but not necessarily TV, because with TV you already tuned around it anyway. So we're constantly working in the same range as TV is. We can't avoid that. There are some cities that there's no adjacent TV channels to where your stuff is fitting in. So you have some room to breathe a little bit. But just remember, if you put everything in the right open space and a TV station is right next to you, using a directional antenna is going to just help you get your coverage. It's not going to help TV get out of the picture. It's what helps TV get out of the picture is if you use filters on top of using directional antennas. So again, this can lead to this is a whole nother webinar, but looking at the spectrum like I'm going to show you next week how to do this, how to choose the right channels to use on top of choosing the right antennas.
In the frequency coordination webinar, go to our website, go all the way to the bottom, and you'll see a place there to register for that webinar. So the short answer to that question is no. The directional antenna doesn't keep you safe from digital television.
Yeah.
Cool. Good answers, guys. And, of course, always email us at info@rfnu.com if you want a one-to-one consultation. Richard, Bob, myself, and Danny, we're all looking at that email address, so we can always help with any advanced questions for sure that we didn't get to today. Let's get to the next couple ones here, guys. What is the easiest way to coordinate different brands in the same system? Shure, Sennheiser, and RFNU components.
All right. So coordination can mean a few things, a couple things. If you're saying you want to just use different brands with the same antenna system, that's what we do. We work with all brands, and it just means that our antennas, our distros and combiners will work with any brand. With that being said, if you're talking about coordinating the frequencies, that requires practice and an expertise, and just going into, for example, our system builder will do that easy for you. With up to a certain amount of channels. Let's say you use 20 channels, you can use our wireless system builder to get you going. If you're doing complex shows where there's the amount is changing, the amount of channels you use are changing, or you have people bringing in different things per different events, then that's where you jump into wireless workbench and Soundbase, because now you could take one or two pieces out and add and subtract things and manage it differently. So I would say, to answer this question in the most simplest form, is use our equipment, yes, because it works with all brands. Don't. I would not let a brand tell you that only their distro would work with their mics. That's a common thing. And then when it comes to actually energizing things up, use the proper coordination tools, frequency coordination tools, to get them going. And again, start with System Builder. Just get used to how to do that. Our System Builder has a lot of the brands in there, so you can start mix and matching whatever you want.
Cool. All right. Last couple questions, I swear. What's the maximum number of IEM transmitters that you should use with a single antenna?
Okay. I'll go for this one.
Yeah, Richard.
Okay. So normally a combiner is 4-channel, 6-channel, 8-channel. There's not one that's a 12-channel, like an active combiner. Meaning you got to decide what your total amount is. And the good thing about our combined 6, when you use them both together passively, having 12 IAMs is a good amount. Like takes it above the 8 to 10 mark. If you go beyond that, I would just consider you can passively combine more, but then you lose your signal to noise. Your signal to noise starts to be compromised. So that's where you have to decide: do I just run another antenna out? Now, if you use 4 combined 6s and you passively combine 2 pairs of them, that's 24 IEM channels. That's a lot. So, but it doesn't mean that people don't do that. But it's common to have 2 antennas out for more than 12 IEM transmitters. So no problem with that. You have to plan on running 2 antennas out in some cases.
Great. Yeah, definitely check out the Combine 6, because I don't think there's any other products on the market like that where you can stack 2 together in a single rack space with a single CP. And as Richard said, adding the additional antenna helps reduce the intermods between the systems. So that's always been a good recommendation. More expensive, but the best recommendation to run it. All right, last question. What makes an antenna effective for a specified range of frequencies?
Okay. when antennas are produced, they are sensitive to a center frequency. So like for example, they have a range that they cover, but its sensitivity covers generally the center of that range. And a lot of times the good antennas, like if you were to measure our antennas, they have the sensitivity across the spectrum. When you start getting to the ends, it tends to taper off, but generally the good antennas, like when you if you were to test ours or use even just use ours, you would notice that when you're at the edge of the range, it still is super strong. Now, just to imagine that if you're talking about the normal UHF air, so if you're talking 470 through 615 megahertz, when an antenna is a wideband antenna, it generally works for all of that. There are less antennas out there that are not wideband anymore. So I would just look for the total coverage range you possibly will tune to and select the antenna. What's cool about some of our antennas, it goes above 608, which means you can use other things even in the 900 megahertz range. So what I would do is just look at our specs and see if you're going to go above 608, see which ones cover that. But most antennas out there are considered wideband antennas.
Great. Yeah. Antennas don't just stop working when the print spec says they do. So keep that
Yeah,
in
yeah.
mind.
Yes, yes.
Well, that's all the questions, guys. Great questions, great feedback in the Q&A. Definitely thank you for your time, and certainly ask us any questions, that you have. We're always willing to help. And I saw Richard asking for one-to-one consulting meetings. So definitely let us know if we can help any further. Thank you so much. Looking forward to see you on the next webinar. We will be sending you this feedback form. Definitely let us know how we did. We always want to know how we can improve, and we'll be looking at how you score us. So thanks again, Danny. Thank you, Richard. And thank you everyone for your time.